Okay, so I asked you to memorize the solubility rules, and it's really important that you know those because you have to know how to do these. You have to know how to use these on the AP exam, and you will not have this. So do what you can to get these memorized. If you are struggling, I liked when I saw this that it was nice and pretty simple. It's going to cover 95% of what you're going to come across. You got to remember what the ions are that are always soluble. So nitrates, any of the group 1 alkali metals, anything with ammonium, anything with an acetate, anything with a chlorate or a perchlorate. So these are the things that are always going to be soluble. And then there are some that are soluble with some exceptions. So your halogens, your chlorine, bromine, and iodine, with the exception of those 3 that are pretty close to each other on the periodic table, the lead, the silver, and the mercury. And the same 3 are exceptions on the sulfates. So sulfates are going to be soluble unless they're with those 3 or the 3 that are together in group 2. Okay, precipitation reactions, it's when we mix 2 ionic compounds that are, or aqueous solution of ionic compounds, and a solid forms. This is called a precipitate reaction. And it's actually sometimes also called a metathesis, an exchange, a double replacement. Okay, so metathesis means to transpose, and a double replacement reaction requires some driving force to proceed. Now, at least in my class for Honors Chem, the only driving force that we looked at is it had to make a precipitate, a solid, but there's actually 2 others. So we want to look to see whether or not a precipitate forms. If a precipitate forms, that means that we have a reaction that's occurred. If it doesn't form, then, and the other 2 things don't form, then that means that nothing's reacted, nothing's changed. The other thing is, and this is what you'll see mostly in acids and bases when they react, is the formation of a molecule. So water, if water is formed, that's a molecule. And if water is formed, that means that we have a reaction that moves forward. Gas. Okay, so let's take a look at each of the 3. So if we have an insoluble compound, one that forms a solid, then a reaction occurs, right? So here's the example here is silver nitrate and potassium chloride. They're going to make potassium nitrate, which is soluble because both alkali metals and nitrates are soluble. And they're going to make silver chloride, and silver chloride is insoluble according to the solubility rules, so it's going to precipitate out, and you will have a reaction that goes forward. Okay. Hydrochloric acid is added to a solution of sodium hydroxide, so what's going to happen here is we're going to make potassium chloride and water, and that water is a molecular compound. So therefore the reaction occurs. Driving force of a gas. Now this is the one that sometimes sneaks up on you. It's something you got to watch for. Okay, so it forms a gas. It either can form a gas directly where it tells you it makes carbon dioxide or hydrogen or something you would readily recognize as a gas. And these are all the gases that eventually you should recognize as recognize the compounds that their normal state at room temperature is going to be a gas. Whoops. Carbon dioxide, sulfur trioxide, hydrogen sulfide, the stuff that smells like bad eggs, nitrogen dioxide, ammonia, oxygen, hydrogen. Okay, so eventually you'll recognize all of these as gases. But they can also come from the immediate decomposition of a product like carbonic acid, pure acid, or ammonium hydroxide. So we looked at this in Chem 1, but this is going to form water and carbon dioxide. This is the gas or the product you get out of a sodium bicarbonate and vinegar, baking soda and vinegar, right? Acetic acid. You get carbonic acid, quickly decomposes into water and carbon dioxide. Whoops, this should be carbon dioxide, and this is in there as a gas, right? Just like this will break up into H2O and SO2, right? And we see that sulfur dioxide here is a gas. And this will break up into NH3 and water, right? So these things, when they form, are very temporary, and they immediately decompose into some things that include gas. So if these are your product, then you in fact do have a reaction. So you need to know those three. The others you'll learn over time, but you got to be able to recognize those three, that those do become gases when they decompose. Okay. So let's take a look at this. We have hydrochloric acid is added to potassium sulfite, and when I do that, I end up with potassium chloride, and in sulfurous acids I only need 2 of these. Oops. Let me see. 2 of these, and what I know is this is going to decompose into water and sulfur dioxide, just like if I have sodium hydroxide and ammonium chloride. This is going to make sodium chloride and ammonium hydroxide, and we just said that that's going to decompose into ammonia, which is a gas, and water. And the fact that we make this gas or make this gas tells us that the reaction goes forward, it completes.